Exercise 18. So we've just been talking about limiting reactant problems. We just went through a long example problem. Let's see if we can do this on our own. Nitrogen gas, nitrogen N2 can be prepared. So I'm preparing this. That makes this the product by passing ammonia. And this is going to be a reactant over solid copper 2 oxide. Again, reactant at high temperatures. The other products, in addition to nitrogen, are solid copper. Right, so that's just Cu and water vapor, H2O. So before we read the rest of the question, I'm just going to write down my equation. So NH3 is gaseous, so I might as well write that down. Over solid copper, reacting to form, and my first product was nitrogen gas, the more important one. Where's my other stuff? Other products are, oh sorry, this is copper oxide. My bad. Right, passing over solid copper 2 oxide. Yeah, that's my fault, because copper solid has to go over here as a product. Right, the other products are solid copper and water vapor. Now let's balance it. Nitrogen here, nitrogen there. It's 2, so maybe throw 2 right there. So my nitrogen's balanced. Hydrogens, looks like I have a 6 there. 2 there, so I could balance that by putting a 3 right there. Next up, my coppers. There's 1 there, 1 there. So that's already balanced. Let's look at my oxygens. I have 1 there, but I have 3 there. So I'm going to have to put a 3 right there, which increased the number of copper that I had, but that's easy because copper is elemental over here. I could just put a 1 in there. So 2 nitrogens on both sides, 6 hydrogens on both sides, 3 coppers on both sides, 3 oxygen on both sides. All right, so I think we're good. So our mole ratios are going to be 2 to 3 to 1 to 3 to 3. The other piece of information that's nice to just get it done and get it written down is the molar masses. So again, feel free to pause this and calculate these on your own to double check my calculator work. It's always a good idea to check your calculator work, because even though the calculator is a machine, you are a human, and it is very easy to type something into your calculator incorrectly. Okay, so we have a bunch of foundational information ready to go. So let's finish reading the question. If a sample containing 18.1 grams of ammonia, so let's get a little space, 18.1 grams there, is reacted with 90.4 grams of the copper 2 oxide, so this is going to be 90.4 grams. What's the limiting reactant? How many grams of N2 will be formed? So 2 questions. Which one of these is going to run out first? Second question, how much of this in grams will I actually end up making? So first, what we need to do before we can use these mole ratios is to calculate how many moles of each of these things are in fact present. So give me your calculator. 18.1 divided by 17.04. shows a lot of calculator involvement. I'm going to use 3 significant figures, so to 1.06 looks like 1.06 moles, and do copper 2 oxide. It's going to be that 6 will round that up to a 4, so let's go 1.14 moles. Now, here's the nice thing about the table. Notice how there's 3 copper 2 oxides for every 3 coppers and every 3 waters. It's 3 to 3, 3 to 3. And so this mole value is going to be the same here and here, if I can write it. Right, because they have the same mole ratio, so 1.14 moles. Now, I don't know if I'm going to need that right now. Actually, I do know that I'm not going to need it. But it's nice on these longer free response questions to have this information written down, so it's right there in front of you. You can pick the information you need out. What I actually need is this, but I'm going to have to wait for that. First question, which one is limiting? Which one is limiting? So let's play the what if game. What if all of the copper 2 oxide reacted? What if all the copper 2 oxide reacted? So there's going to be this many moles of copper 2 oxide. Now, it's a 3 to 2 ratio, so I'm going to have to divide by 3 and then multiply by 2, right? It's a 3 to 2 ratio. So I divide this number by the 3 to get this down to if there was 1 mole, and then I multiply it by 2 because in fact there's not 1 mole, there's 2 moles. So if all of the copper 2 oxide reacts, I would need 0.75. Let's see, 3 significant figures. So let's call this 0.7. Let's call it 758 moles. Do we have that much? Yes, we do. Yes, we do have that much. And so I'm not going to use all of this. I'm going to use the 0.758 moles. That's how much I'm going to actually use. So that means, because there's leftover here, it means that this one is limiting. Therefore, this one is in excess. Fair enough? So, since all of this is going to react, I'm going to produce, right? So I've answered one of my questions, right? CuO is limiting. So one of my answers, I need one more. How many grams of N2 will be formed? Well, since all of this is going to be completely consumed, and they occur at a 3 to 1 ratio, 1/3 of this will be produced. So let me go back up here and pull that number, divide it by 3, and this is the number of moles of nitrogen that will be produced. Let's see, I need 3 significant figures, so I'll go 0.379. Yeah. 0.379 moles will be produced. Am I done? No, I'm not. I did figure out how much nitrogen is going to be produced, but I'm supposed to answer it in terms of grams. How many grams will be produced? So simply convert from moles using the molar mass of nitrogen. So all we have to do is multiply this number that we just got by the molar mass of nitrogen, which is 28.02. Because remember, it's diatomic. And so we are going to produce 3 significant figures. So I'll go 10.6 grams nitrogen produced. And so we've done the big, long, annoying limiting reactant problem.